Hello everyone, Miss Hanley here. This is notes number 10 that will coincide with assignment 10, graphing inequalities in Unit 2, Systems of Equations. You should have just completed your quiz over solving systems of equations, or you might be past that already. And now we're going to not only solve systems of equations, we're going to solve systems of inequalities. But first we have to remember how to graph an inequality, so that's what this lesson will be over. So you should already have these notes in your packet, so you can fill these in as you go and then try the graphing worksheet afterwards. So let's begin by talking about the steps to graphing a linear inequality. So we're talking about graphing here, and especially when you're graphing inequalities, the easiest way to do it is from slope-intercept form. So any equation or inequality, that you get, you want to put into slope-intercept form first. So that's my first step. Put equations, nope, I keep using the word equation, sorry. Put inequalities into slope-intercept form. And if you remember, that is your y equals mx plus b. Alright. Then your second step would be to actually graph the equation that you were given, or inequality in this case. Graph the inequality. So just graph the line, find the points that will go on that line. Once you have figured out where the line will be, then you have to decide, because it's an inequality, if your line is going to be solid or dotted. So you want to determine if you have a solid or a dashed or dotted line. You can call it either. And the reason that you're doing that is because when you graph an inequality, or when you're dealing with inequalities, you don't have just one answer. You're going to have everything that's either less than or greater than some value, some line. And the dotted or the solid line tells us whether to include points that are actually on that line in our solution. So if it's a solid line, all of the points that follow that line are part of your solution. But if it's a dotted line, that's when you would just have anything that's shaded to the left or the right of your line. Which brings us to our last step. So we've put our equation or inequality in slope-intercept form, we've graphed that line, we've decided if it's solid or a dashed line, and so lastly we need to decide whether to shade above or below that line. Okay, so those are our 4 steps that we need to use to graph an inequality, and next we'll actually go through an example. Alright, so before we get too deep into our example, let's go through how we determine whether or not something would be a solid line or a dotted line. We just said that a solid line means you're including those values as part of your solutions. They actually are solutions. And so that means that our solution must be sort of equal to that value, and whatever type of form of equation you have, whether it be slope-intercept or standard form, then you're looking for that equal to sign. So you might have a less than or equal to, or a greater than or equal to. If you see either of those symbols, that's when you want the solid line, because we're actually including all of those points that are on that line. They can be equal to that line. If it's going to be a dotted or a dashed line, that's when you would just have a less than or a greater than. So we're not including any values on that line, only ones that would be above that line or below that line. So let's go through and take our inequality, 2x minus 3y is less than 12. And we want to first, as our steps tell us, to change this into slope-intercept form. So I'm going to start by solving for y equals mx plus b. We need to move the ax term to the left. So I have a negative 3y is less than a negative 2x plus 12. And then lastly, I need to divide away the negative 3. So negative 3 over negative 3, that will cancel. Negative 2 over negative 3x is going to give us positive 2/3 x. And 12 divided by negative 3 is going to be negative 4. And don't forget the really important rule when you're solving inequalities. If you multiply or divide by a negative number, as we've done right here, you need to flip your inequality sign. That sign is going to switch. So it's now going to become a greater than rather than a less than. So we now have slope-intercept form. And we need to answer our few questions. So we want to decide whether it's solid or dotted and whether we're going to shade above or below. Well, for the solid or dotted, we just went through those, solid or dashed. If it's just a greater than symbol in our final equation, we're going to use a dotted line, meaning we're not including those points as part of our solution. So we know we're going to use a dotted line, all right, or a dashed line. And so then let's go ahead and actually graph. Okay, so our second step was to actually graph the line. So this line starts at negative 4 on my y-axis, 2, 3, 4. And from there, I'm going to use my slope as a rise over run. It's a positive slope, so this line should increase from left to right. So we're going to go up 2, into the right 3. And we could keep doing that. We could also go down 2, into the left 3. And so here's our line. We said that we need a dotted line or a dashed line instead of a solid line. So when you connect these points here, you don't want to connect it with a full solid line because that's not a true statement anymore. So we used our dashed line, and now we have to determine whether we're going to shade above this line or below this line. So if you see, when we're talking about solutions to a system, if you are shading above a line, well, that's going to be values that are larger or greater than the line that you currently have or the points that you currently have. So if I'm going to shade above, I would see either a greater than or a greater than or equal to sign. If I'm going to shade below, then I would have a less than or a less than or equal to sign. Well, since we have a greater than symbol, we're going to shade above our line. So we're shading in this half plane above, and I just looked at my line and said, okay, well, above would be the top left corner there. If you're ever not quite sure which is above or below, you can pick what we call a test point, and usually 0, 0 is a great test point. You can substitute that into your inequality and see if it's true. So for example here, if I substitute in 0, 0, we're going to have 0 is greater than 2/3 times 0 minus 4. Well, that tells me 0 is greater than negative 4, which is a true statement. So if it comes out to be true, that means that point is part of my solution. So everything that we've shaded up here is going to be part of your solution, and if you use that test point and you weren't sure, that test point tells us, well, if that's a true statement, then everything in this region should be true as well. So the solution to your system is everything that is shaded, all the points shaded above that line, but not the actual points that are included on that line. So the point 0, negative 4 is not a solution because it's part of a dashed line, but the point 0, 0 or 1, 1 or 0, 3 or negative 3, 3, any of those points that fall in that shaded region would be considered a solution. So now go ahead and try the ones that are on your assignment 10 worksheet.